Hello, welcome back to Teacheetah differential equations. So today we're going to open a new chapter as exact differential equations, which is really important, and later on we're going to continue on this for several lectures. So an exact differential equation is, imagine we have this differential equation in the past, correct? And q, x, and y, dy equal to 0. If dp over dy is equal to dq over dx, we call this equation exact. But what happens when it is an exact equation? Then we can say that there is a function u, x, and y where du over dx is equal p and du over dy is equal q. Now if we place this back into this equation, we see that du is equal to du over dx plus du over dy, which basically du is equal p dx plus q dy equal to 0, or basically du is equal to 0, or u is equal a constant as a function for x and y. And when we have this type of differential equations, they are easily solvable. So let's take a look at an example. We say dy over dx is equal 3x squared plus y cosine x over 4y cubed plus minus sine x. So if I open this up, we basically get to 3x squared plus y cosine x dx plus sine x minus 4y cubed dy equal to 0, which this is p and this is q. So now let's do the test. Let's see if it's an exact equation. So I'm just going to calculate dp over dy, which is cosine x, and dq over dx, which is cosine x. So therefore it's an exact, correct? So now we know that there is a u function where du over dx is equal to 3x squared plus y cosine x, which basically means u is equal x cubed plus y sine x plus f of y. We are interested in finding the f of y, and then we have solved the equation, right? So we can say from the other side of the exact equation, du over dy is equal to sine x plus f prime y, right? We are just taking this equation based on y, and also we know du over dx is equal to p and du over dy is equal to q. So sine minus 4y cubed, or this one. and this is from here. So du over dy, from this equation we're gonna get this, and we also know du over dy is gonna be equal to q, which is this one, right? So now sin x is gonna cancel out, and then we know f prime y is equal to minus 4y 3. So basically u is equal to x3 plus y sin x minus, oh sorry, here. So we know fy is equal to minus y4. This is simple, right? We're just gonna simply integrate. Minus y4, and then we know this is gonna be equal to a constant. So basically this is the answer to this equation. See how simply we can solve these equations? So let's take a look at another example. In the next example, we are saying find a so that below equation is exact. Let's take a look at the equation. A y e to the power of xy plus 2xy dx plus x e to the power of xy plus x squared dy equal to 0. So as you can remember, if it's an exact equation, we're gonna have dp over dy is equal to a e to the power of xy plus axy e to the power of xy. So we are basically looking at this equation, right? This is p and this is q, plus the rest, and then we're gonna do dq over dx equal to e to the power of xy plus yx e to the power of xy plus the rest, right? So in only one case, if you compare these together, these are supposed to be equal, right? In only one case these are equal, right? Where a e to the power of xy is equal to e to the power of xy, because there will be no other e to the power of xy in the rest of this derivative. So a has to be 1. Correct? Let's take a look at another example. Y dx plus x minus y squared dy equal to 0. So now we can say u is equal to integral of y dx plus fy, or basically u is equal to yx plus fy. So therefore du over dy is equal to x plus f prime y should be equal to q, right? Same as we saw before. So basically f prime y is equal to minus y squared, or fy would be minus 1 over 3 y cubed. So u would be equal to yx. We're just gonna put this back in here, right? Yx minus 1 over 3 y cubed, which is equal to a constant, and this is our answer. I'm gonna continue with one last example and then we will end the lecture at this point. So we have x plus y dx plus x minus y dy equal to 0. We know y of 1 is equal to 1. Question is asking what is y of 0. Correct? So again, we can start. We know that we have p and q. So therefore, we're gonna say u is equal to integral of, this time I'm gonna start with q. There's no difference, right? So x minus y dy plus fx this time, right? Because this is dy, this would be fx. So basically u would be equal to xy minus 1 over 2 y squared plus fx. So du over dx would be equal to y plus f prime x, and it is equal to p, right? Which is x plus y. From here we can say fx is equal to, f prime x is equal to x, therefore fx is equal 1 over 2 x squared. So therefore we're gonna have u is equal to xy minus 1 over 2 y squared plus 1 over 2 x squared equal to c, and then we know y of 1 is equal to 1. So basically 1 by 1 minus 1 over 2 1 squared plus 1 over 2 1 squared is equal to c. So this cancels out with this one, and from here we know c is equal to 1. Now we're gonna see what is y of 0. So 0 by y minus 1 over 2 y squared plus 1 over 2 0 squared is equal to 1. This is 0, this is 0, and from here we know y squared is equal to minus 2, and then y would be equal plus minus 2, or you know that square root of minus 1 is I, and then so forth. That's how we're gonna solve these equations. That would be it for today's lecture, and see you guys next time.